All right, so looking at our points, lines, planes, homework. All right, the big thing here is really just understanding our definitions. All right, because in order to answer these questions, you need to know what it's asking, right? So our first question is asking for collinear points. All right, 3 collinear points. Okay. So we need to know what collinear means, and we also need to know how to name things, right? So collinear, right? The word line is in there. That means points on the same line, right? And we're looking for 3 of them, right? Now there's multiple answers to most of these questions, right? So we're looking for 3 points that fall on the same line, and the first one that just jumps out at me is right here. Here is a line, right? Line A and X, or line AX, however you want to call it. There's a whole bunch of names for that. All right, and it has 3 points, and we can see them. We have point A, point N, and point X. All right, so those are 3 collinear points. All right, so we just go over here and say point A, point N, and point X. All right, and that's what most of these questions take, right? You need to understand what a line is, right? A line extends for infinity in both directions, right? So again, AX, that is a line, right? CM is another line, and R, I know we cannot name it, right? Because there is no other point on this line, or sorry, RN, right? RN, right? That is another line. All right, so how many distinct lines are in this picture? That's a pretty simple one. There are 3. All right, not going to do all of these. I'll jump down to a few more where people tend to have issues, and that would be naming a plane, right? So to name a plane, remember there are 3 ways to do it. Okay, I gave you one way, plane V, right? I put that in the lower corner right there. All right, so we could call that plane V. However, you cannot reuse that. All right, now the other way to do it is you need 3 points. 3 points. All right, and the key here is they cannot be collinear. So for example, I cannot use the 3 points A, N, X because they fall on the same line. I could use 2 of them. I could use A, N, but I have to choose a third point that is not on that line. So for example, I can use A, N, C. That is an appropriate name for this plane. All right, I could use M, R, and X. Those aren't on the same line, right? As long as all 3 of them are not on the same line, you can name it as the plane. So I'll use plane ANC. All right, and again, to name it, you just go over here. Since I'm using 3 letters, we would write out the word plane, and then our 3 letters, A, N, C. All right, plane. I believe my other letters were R, M, and X. And again, order does not matter. All right, jumping down to our always, sometimes, never true. Right, you really need to understand our definitions and how we name things for you to get these problems. Right. So the first thing we're talking about is array. Right. Okay. So just off of an instance, right? Array. Right. Array is a segment or is a line that extends infinitely in one direction. Now remember, to name a array, we always start with the end point. We always start with the end point. All right. So for example, ry, right? This end point has to be r. All right. And the other array, yr, All right, since I'm starting with y, this endpoint needs to be y. Well, let's think about it. All right, if I'm calling this r and this y, all right, this is r and that's y, can these be the same ray ever? And the answer is no, they can't be. They have two different starting points. All right, so no, they cannot be the same ray. Okay. Right, and so forth, right? Again, you need to understand, you truly need to understand the definitions. And if you understand the definitions, it makes these problems much easier. I guess we could look at one more. It doesn't really matter which one. Maybe 14, a plane, right? So we're talking about a plane here. So you need to understand what a plane is and what points are. So first and foremost, what is a plane? Well, a plane is a surface that is made from lines, right? Infinite amounts of lines. All right. Well, what's a line made out of? Well, a line is a infinite amount of points. So if a plane, right? If a plane is a line, right, it's an infinite amount of lines, and a line is an infinite amount of points, right? Can a plane contain only 3 points? Absolutely not, right? A plane has an infinite amount of points, right? Now, we may only label 3, so don't get confused with that, right? I can draw a plane here, all right, and I could just label 3 points, right? So I can name it, but are these the only 3 points in this picture, M, X, and L? Absolutely not, right? There are an infinite amount here. Okay, moving on to the back. Really just intersections, right? So I find it helpful to highlight maybe, but we also need to understand what we get when we intersect two things, right? If we intersect, these are our postulates, if we intersect two lines, right, if two lines collide, they collide at a single point, right? If two planes collide, right, think about this as like your walls, right, where the ceiling meets the ground. Do they only meet at one point? No, they meet on the whole line of the ground. Right? There's a literally a line formed when the ceiling and the ground hit, or sorry, when the wall and the ground hit, or the wall and the ceiling hit. Right? It's a whole line. It's not just one dot there. All right. So when we're talking about plane DCG, all right. So plane DCG, all right. That's this whole wall. DCG is this whole wall. And then we are talking about EFG. Well, EFG is this whole wall. So the question is, what line do these two collide on? And I find it helps when you highlight, all right, because now you can see what line do my two colors overlap on. All right, we can see they overlap at HG, and it is a line, so, or a segment, so it is HG. All right. 18 and 19, you're going backwards, right? I'm telling you to look at CD, right? Look at the segment CD and what two planes intersect there, right? Well, that would be ABCD and my blue plane, right, over here, plane DCG again, right? So those two planes are the ones that intersect for that, for number 18. All right, 20, we're talking about lines and their intersections. All right, remember when two lines intersect, they intersect at a single point. All right, again, I find highlighting is very helpful for that. In order to make this a little shorter, I just want to jump down here, plot the points and state if they're collinear. Right, so again, this is using some algebra. We need to know how to plot points. Right, remember to plot points. Right, Order pairs are labeled x, y, right? Your x-axis is your horizontal, right? I even labeled it nicely in this diagram for you. X is horizontal, right? So these are your horizontal counters, right? Y is the vertical, so these are your vertical counters, right? So when we're looking at the picture, right? If I'm going -1 on the x-axis, +1 on the y-axis, that point falls right here. I'm going +2 on the x-axis, -2 on the y-axis, that point falls here. I'm going +4, -3. So the question is, are these points collinear? All right, which means, do they fall on the same line? All right, now there's a few ways you could handle this. All right, you could get a ruler out and try to connect all these. All right, so the question is, do these all fall on the same line? And hopefully you can see that they do not, right? If I want to try to make it happen, all right, I need to curve it a little bit. And I don't want to curve it, a line is straight, right? The other thing is understanding slope, right? Lines have slope, all right? They all fall on the same slope. So, all right, and remember, slope is rise over run, all right? So if I'm going to count each point, down 1, 2, 3, to the right, 1, 2, 3. So my slope is, between these 2 points, is 3 over 3, -3 over 3. That's -1, right? When I move down from my other points, I go 1, down 1 to the right 2, right? You could see that the slopes are different, right? From my high point to my middle point, my slope was -1. From my middle point to my low point, my slope was -1 over 2. Completely different, so no, right? These are not collinear. And we would play the same game for 27.